Good afternoon and welcome to the InHand Networks Energy webinar on this 10th of April. Appreciate everyone joining today. This will be recorded and available for download on our website after the call. My name is Sam Watts. I'm the Vice President of Business Development for InHand Networks in North America, specifically covering the energy and utility segment. I've been in the segment about over 15 years in the smart grid. I've been here at InHand about 1 year, and I'm located in Atlanta, Georgia. In today's webinar, I'm going to go through a little bit about InHand Networks, then go through some of the product line, including the ruggedized industrial cellular networking gear, and then shift into a brief discussion of our medium voltage overhead distribution line sensors and associated artificial intelligence and fault condition capability. And then I'll open up at the end for questions. I believe I'll leave it in a chat format for questions, so we'll take that through. I don't expect this will take the full hour. I'll try to move quickly and just kind of hit the highlights. So again, InHand Networks, we're an Internet of Things or IoT company. We've been around for 19 years now. About 19 years. So I founded in 2001. My four co-founders. I work for one of the co-founders who's here in our Virginia office, Li Ming. Built a blue chip customer base over the years, including long-time relationships with companies such as GE. GE Healthcare uses over 10,000 of our industrial cellular routers in their MRI and CT scanning machines, including our cloud software for remote management and monitoring. We are a global company and have customers all over the world, including the state grid of China, which is where a lot of the overhead distribution line sensors are today, in addition to other parts of the world. We do partner heavily in industrial controls with both Schneider and Rockwell, and have brought a number of new production factory capabilities online in the last few years. We are publicly traded on the Star Market Tech Board, and all of our financials and operating results are available through outlets like Bloomberg.com. Global company, about 300 employees and a total sales of over $40 million last year and quickly growing. We produced and designed and shipped close to 400,000 IoT products just last year. And we expect that to reach, even with the slowdown, over 400,000 this year. And we are on schedule to open our new factory in China in Q2 of this year, which will be 4 facilities for us now in production. We don't do any contract manufacturing or outsourcing. Everyone in research and development, which comprises 30% of the firm, is employed by InHand. I mentioned some of the leading technology partnerships that we offer here on the left, including a lot of work with Amazon. On the AWS platform, which is all of our software runs on. We're also heavily in the smart grid, of course, with firms around the world, including Aramco in Saudi Arabia, some newer customers in the United States, also strong with Latin America, as well as some of the customers in Europe and Asia that you see here. Also, you can see blue chip customers in other segments as we operate devices into ATMs, financial machines, point of sale, vending machines, and other segments. Everything that we do is under an ISO 9001 regime, high quality. And we also support all the certifications and standards across our product lines that you would expect. And I'll go through some of those specific sort of sector or product specific features in a moment. Everything we make and sell is under a 3-year warranty. So we stand behind our products and our heritage. We do offer free technical support here in the US out of our technical support office and sales office in Fairfax, Virginia, right outside of DC. And we have that staggered even today with 16 hours per day, 5 days per week. And of course, someone like myself here in Atlanta, easy to reach and easy to work with. So we are not a giant company like some of our competitors, a mid-sized firm, and about 10 of us here in North America, and happy to provide personalized sales and service. The product line is really 3 layers. So there's the IoT hardware. And I'll go into each of these devices in a moment briefly. We then have our cloud platform for remote management and configuration of all of our devices. And that actually is a very low cost and sometimes mostly free offering this year. We have some specials around that. I think help you get started using the InConnect product. We also have vertical specific solutions, including in the smart grid, which I'll get more into in a moment, around the line sensors, but also making ATM smart, point of sale and vending, as well as remote monitoring solutions. All of the main sort of money maker for us, or keeps the lights on, is this networking communications gear. And in particular to energy and utility, we are a major supplier to energy and utility customers across the globe, with over 1 million devices installed into power utilities and grid operators globally. All of these devices are very rugged, almost indestructible type, hardened environments and wide temperature ranges. Very reliable, and I'll go into why we have some patented features that allow the devices to sense errors and reboot and recover and have a lot of backup capabilities. We also, of course, in operating in sensitive environments, including utility, production facilities, control facilities, robotics, feature all the right security. We know data is important to you, and we feature a lot of development and standards and certifications around security as you go down our product line. And carrier certified, we work globally with many major carriers. Here in the United States and Canada, you have relationships, with Verizon, AT&T, T-Mobile, Bell Canada, and others, also Sprint. And we have some positions here in the States devoted to those relationships that we nurture and work closely with our carrier partners. So the lineup is everything from a high-end router, a lower cost industrial router in the 600, a gateway product, 4G LTE chips, as well as inexpensive serial cellular modems. And then our new gateway product that provides a mobile hotspot in a fleet vehicle. I'm just going to mention each product on one slide. I'm not going to go in any sort of depth on this call today. The in-router 611 and 6115 are low-cost industrial cellular LTE routers. These are going to be mostly plug-and-play units that are going to work in a wide variety of use cases. I know since I've came on board, I've worked with this product in solar inverter monitoring, both electric and water meter monitoring and communications, as well as some substation applications. These feature a variety of speeds and configurations, everything from Cat M1, which is low cost, low bandwidth communications, specialized for machine-to-machine applications, all the way up to Cat 4, higher speed, higher bandwidth applications. And all of these, of course, feature all this right security and reliability that you would expect from industrial company. We do feature all these with the remote management, as well as a rugged design with wide temperature ranges, IP ratings. For applications that require more power and some ability to run a script or a program, we feature the 9 series router, and these are available in a 2 Ethernet port or a 5 Ethernet port configuration. These are going to be certified on both the Greengrass, AWS, and Azure platforms for development, and also feature enough CPU and RAM to run Python programs and other applications on top. Also, these are going to have dual SIM capability, as well as more redundancy as well built into them. The NDTU is a simple device, but it's extremely popular for us. So we've placed more than 800,000 of these NDTUs into power utilities worldwide. These are simple devices connect by an RS-232 or 485 serial port to some sort of power line controller or RTU, or anything you have there that communicates that way, both Modbus, protocol conversion, as well as IEC, as well as a pass-through mode. These would connect, particularly on Verizon 4G LTE. These operate very, very low, or require very little power to operate, and can have a very low power drip at a standby mode, as well as featuring electromagnetical resistance up to level 3 and an IP30 rating. These are sub $100 and reliable units. You can find these in applications as diverse as SCADA, RTUs, and street lighting monitoring and controls. Our most advanced product is our industrial gateway. This does do routing, of course, but is more of a edge computing device, supporting a wide variety of protocols from Profinet to Modbus down to MPI and PPI. The ability to run extensive Python scripts and programs and communicate back with MQTT as well as HTTPS. Featuring abilities to run all sorts of custom applications. Typically when I work with customers on this, it's more of a specification and they kind of know what they're looking for here, but a powerful edge computing device that's ruggedized with high temperature ranges, high security, redundant hardware watchdog features in the Linux operating system, and other advanced features that make this one of the best gateways we find out there. And I'm working with a number of larger grid firms, I'd say, on some applications around transformer monitoring, as well as some other monitoring and use case applications. So this is a popular device right now. And then our newest product in the networking line is our industrial vehicle gateway. And this is terrific. Up to Cat 6 high speed or LTE advanced speeds, featuring a gigabit Wi-Fi and gigabit Ethernet in the vehicle. Very secure, able to create with dual SIM capability and redundancy, create wireless hotspots in the vehicle for secure applications, as well as all the VPN and tunneling features you'd expect. This is a newer product for us. We're getting a lot of interest and is priced right, like everything we do. So those are the sort of the one half of my brain that I use week to week. These types of networking devices where you're looking at industrials, reliability, performance, standards, security. The other half of my brain that I spend another 50% of my time on is these sensors. And it's a little different, but we do use some of the same common technology, as I'll explain, and why this makes sense for us as a company. We have come out with more of those value-added products to align with our different sectors, as I mentioned at the top of the call. And this is our strongest offering into the grid. So what these are overhead line sensors that go on medium voltage distribution power lines. These can go currently from 10 kV to 35 kV applications, and we plan to range that up to 69 or higher next year. They collect and use line harvesting for their power. As I'll get into, they only require 1 amp of power for line harvest at full function mode, which leads globally by several amps versus all the other sensor competition out there. So it's very important in a long line, little load, not a lot of customers type situations, or just being able to use the sensors in a wide variety of applications and locations along the grid. The sensors work at 24/7 at 256 cycles a second, sampling and measuring the current amps, the E field, the harvesting voltage, the temperature of the line of the conductor, as well as have a feature a time clock and a GPS. There's 3 sensors, typically up to 9 from one base station, but typically we'll see 3, and those go on each phase. 1 goes on each phase. And they're easily installed, as I'll get into, with a standard utility hot stick on an energized line. They form an RF connection within 100 meters or 330 feet to a base station, or we call it a concentrator, or you call it a gateway unit. We have 2 versions of it. Currently today, we do most of our business in this pole-mounted unit, featuring a solar panel for its power. And then we have a line-mounted one coming out in Q3. And the line-mounted uses harvest power from the line also. The concentrator does 2 things that I'll get into. It features our fault algorithm running on it, and it also kicks the data back to the data center via 4G LTE, soon LoRa, and available for AMI integration also. And that gets it back to our analytics platform, which runs on Amazon Web Services or on premise and features the ability to configure, diagnose, look at the sensor data, and manipulate all the data. We can also take all 368 data elements from the concentrator and pipe that directly in via DMP3 or IEC internationally to a SCADA system or DMS, ADMS system as well, and tie that together for you. And we offer that as part of a pilot program. These sensors have been out for a few years. We developed the artificial intelligence about 4 years ago. It is patented in the United States. And is based on facial recognition technology. We have over 120,000 sensors today globally, and we have quickly been securing pilot projects in our 60 hertz version that came out last year, both in Latin America, South America, and North America. We have a number of pilot projects today at leading utilities around the globe, and are looking to certainly deploy the solution more broadly and widely this year. To dive in a little bit about the sensors are lightweight. They're a little less than 2 pounds and clamped securely onto the line. As I mentioned earlier, they do feature this full functionality mode as low as 1 amp line current. They actually will continue working at below 1 ampere down to about 0.3 amps. Just picking up ground faults and limiting the cycles of reporting a little bit. They are IP67 rated, feature an industry-leading temperature range, very tough units, 10-year service life, do feature a supercapacitor for up to 12 hours of operation in a total power loss that will automatically recharge when the power is restored. I mentioned the high accuracy, 0 to 630 amps, 0.5% accuracy range, and a similar accuracy range for the E-field and harvesting voltage. So we have this very interesting fault algorithm that we developed 4 years ago, as I mentioned. This is running actually in the concentrator in the field. So this is running in the field on the edge, and it's continuously running and going over the incoming sensor data that's being sent in that 256 times a second. We have a database of 28 million current waveform and fault conditions that our algorithm has been trained to recognize these common fault conditions. So today, we can recognize and provide details around what the statistics were in terms of the magnitude of the fault, the length of it, and all of the waveform recordings and technical information for these type of conditions, such as you can see, short circuit, inrush current, lightning, power outage, restore, and grounding, and also other events. Our accuracy rate is over 95%. It kind of ranges depending on the type of fault, but they're all 95% or higher. And there is tuning of the algorithm very specifically in the software, where you can dial it back a little bit, make it more aggressive, take out certain types of faults. It's very configurable so that you're able to, as a user, very visually and easily make it work for you. The platform, as I mentioned, is available both in the cloud on Amazon or on-premise for a utility, perhaps that post-pilot as we get further into the environment. The software is very easy to use, very visual. The green dots you see here represent sensor locations, typically 3 sensors and a data collector. You can draw the lines, set up all of your topography, loading custom GIS layers, point and click. When you click on a sensor, it pops up the data, retrieving that data, and shows you in a very easy to read way and understand way your situation, with the ability to look at recorded waveforms, trigger events, turn the fault indication light on and off, that sort of thing as well. The software also features a lot of good analysis and reporting tabs to it. In analysis, you can look at the event queue, look at all of the events the algorithm has picked up, follow common workflow patterns, load pictures, notify staff. In the reporting tab, you can look at your load statistics, your communication statistics, really everything you'd want to know. There's 5 to 6 different views there available. And the system tab, there's all the over-the-air configuration of the hardware as well as the software. So you never have to go out to the field and touch the devices or tune or configure or calibrate, unlike some of our competitors. And as I mentioned, all of this, this platform, you can kind of put into as much time as you want. If you want to just take the data from the sensors, put it into SCADA via DMP3. In addition to this, that's something we see a lot and something that can be done. So that you can do a lot of your work on your platform today, and you don't have another software platform to go to at all times. So this can be integrated in, and we support all the right standards and integration methods to do so. These are easy to install. The current version of the sensor does need an installation jig that's very lightweight. We provide that for free, and just clamps around the sensor, opens up the hook, and you push it onto the energized line. And actually, what we found is that the bucket truck method is very good, and half the time you don't really have to use, you don't even have to use a hot stick. You can just take the tool and put it up. The new version of the sensor coming this year, which we're working on some of the just the hardware of it, will actually just have a screw method, so it doesn't require an installation tool any further. We also have an underground product coming this year in next quarter is what we're still scheduled for, I believe. And that's going to also feature the 1 amp operation and the ability to tie in to this same ecosystem of sensor data. So we have received some recognition, done some academics around the IWS over at Sensor Product. We've had some T&D meetings. The Powerline events database that we're using is the largest data set out there that has been used to build one of these algorithms. And particularly the deployment in Asia of these sensors and fault technology and the algorithm is one of the largest deep learning sort of AI use cases in the world for distribution automation. We've actually been accepted by the EPRI in China for their standard of fault detection. So we have good success with this, around the world. This is a product that applies globally to solve a lot of common issues that utilities across the globe are facing. So with that, I'll just kind of recap. We covered the company. We covered our blue chip customer base. I mentioned everything is produced by our own factories with our own people under a high quality ISO regime and features a 3-year warranty and local and free tech support. Just at different kinds of solutions, we have the industrial cellular hardware as well as our cloud services, and then we have these vertical specific solutions, and we kind of highlighted the smart grid overhead line sensors today. We reviewed the products, talked about how there's a basic router, an advanced router, an edge gateway, as well as these 4G LTE pre-certified modems and a packaged serial port modem, and our new vehicle gateway product. And I kind of stepped through each of those. And we took a look at the sensors, the overhead line sensors, 10 kV to 35 kV, inexpensive, featuring a patented algorithm to pick up common fault and condition monitoring indices on the line. And we know that these are technically advanced, also functioning down to an industry leading 1 amp of line current at a high precision with a supercapacitor backup with wide temperature ranges and IP ratings. And we kind of talked about the software as well and how easy to use that is, and comes with the package. At this time, I'll just share my contact information. I'm happy to follow up with anyone offline. Of course, we have a good number of people in here, but I'll go ahead and take any questions by chat, and hopefully I can figure out how to do this. I think in the interface, and I'm a little newer, I think this is Zoom, you can click the Q&A button. Here we go. So let's see here. Question says, in case of lightning or broken distribution cables, what kind of equipment do you recommend to interface with IWS? Let's see here. Just reading that case. In case of lightning or broken distribution cables, what kind of equipment do you recommend to interface with IWS? I'm not sure I understand the question completely, but yeah, if there's a lightning event or the distribution cables are broken, there is a wireless connection. So as long as the sensors are connected with the base station, that's, let's say it's on the pole, that's going to continue to work. But that would be the best I could answer this one, I believe. We have another question. It says, shall I use a solar panel for each sensor? Yes, so for every up to 9 sensors per base station, and I'll show this picture here, within 330 feet. So the base stations, MSRP is like $850, we could sell it for $600 something, so they're not as expensive as some of our competitors. So yes, there's typically a number of these base stations with the solar panels configured or installed, let's say every mile or 2 miles on the same bus bar. Another question, you have a number of questions here. What is the accuracy of the fault location? The accuracy is it's going to know between the sets. So it depends on how closely you cluster them. So if you are looking at the software, let's say, you're going to know, see this red line here? You're going to know between there and there that there's a fault between, and you're picking up what type of fault it is. So you're able to say, okay, it was a transient short circuit event, let's say, and you're able to click into the software. And I don't have the live demo today, and I can certainly do that. Usually I'll show some real customer data when I have more time. So I can show this in another venue, but when you click on the fault in the event queue, it's going to zoom in, show you the data, show you the current waveforms, like you kind of see in the bottom there. So you can see all of both technical details, the visual details with the waveform images, as well as the timing, the type of fault, everything you want to know is in there. In locations where no LTE coverage is available, how does the concentrator operate? You know, that's one thing we're working on. We do have, it does need a cellular connection today. 99.6% of the US population has good cellular connections at this point, according to our latest studies. It only needs a 3G connection also. So I don't have another communication method today, but we certainly are looking at, as we develop in the United States and Canada, that, you know, if we need to integrate with another AMI system or something else on that. So that's something we're open to discussing. Let's see. Another question, with a sensitive earth fault, what is the lowest earth fault current it could pick up on a 3-wire non-effectively earth system? Okay, I might have to take that one back to product to make sure, as my engineering prowess will run out quickly here. I'll take that one back, Roger, around the sensitive earth fault, lowest earth fault current. I'm not quite sure. Let's see. What is the price range for the sensors, also for the concentrators? So you can plan just a general, depending on, you know, everything, as anything else, any other product volumes and channel and everything else. But these are a bargain, frankly. They're probably $2,000 to $3,000 a site for everything. That's, you know, I know this market pretty well, and the overhead sensor market, and that is going to be 3 to 5 times less than there's a, you know, than a true A to B, you know, true comparison point. And that allows you to achieve a greater density of sensors. And as we mentioned a little bit earlier, really any sensor is only as good as how many you have out there and the point of measure. Let's see. Do we provide tutorials to gain insight to the AI learning of our components? Yes, we do. We, you know, I'm easy to reach. We put all of our money into the product as in our service. We're not as fancy with tons of stuff on the web, but we do have a pretty good website. So I'm happy to provide a webinar or some other type of environment post-call. My contact information, of course, I'll make sure to show it here. Happy to go over your use case and what you're looking to do. I have a question, another one from Roger. Could one take the data from the sensor and put it directly into a historian database? I think so. I mean, the data is available, all 368 data points. I've got a bunch of documentation around which exact point values are available and a lot of technical details around that, what's available for mapping. We can serve as a DMP 3.0 server. So it just depends on what database this would like to go into. So that would be something we'd have to look at the specifics. Let's see here. We have a, do we have models that support NB-IoT? The answer is yes. The NB-IoT or NB-IoT standard that's more international, that's heavily supported throughout our product line. We tend to talk a little bit more about the CAD-M LTE side a little bit here domestically, but yes, we have that as well. A couple questions around, do we have air breakers or equipment to disconnect power from lines? We don't have that today. The question around what type of battery or supercapacitor we use in the sensor and how long do we have to change it. From Dylan, I think, I don't know the battery for the concentrator we actually put into the post shipment, the supercapacitors in the sensor. I don't know the brand, but I know that it's a 10-year lifespan on that supercapacitor in the sensor. There is a battery in the concentrator that's super easy to change, and I think that's just going to be, there's different brands on that available, and I don't know the exact lifespan, but typically batteries like about 8 years. If the sensors use a capacitive storage device, what limits the lifespan to only 10 years of operation? My best knowledge on what the lifespan limitation is a little bit of, being on the line. I think the battery or supercapacitor is one of the things, or excuse me, we just spoke about the supercapacitor having a lifespan, as well as just in general, the hook and the CT and everything else. I can get more specifics on what exactly degrades after up to 10 years. All the smart sensors I know of in this space have about an 8 to 12 year lifespan on the spec sheet. So it's pretty common. It's not just ours. Could I provide the presentation? Yes, if you write me a note so I know, I will be glad to follow up with this presentation. There's nothing too special in here. How about using it on high voltage transmission lines? Yeah, absolutely. Right now, I know that we could definitely not guarantee it's going to work on the suggestion of 110 or 135 or even 69. We think it might work on 69, but we haven't verified that. So it's something we're going to have to develop, probably a new product, because it is a different use case on higher voltage. That we believe that would be something that would add to it as well. So we're looking at that after the underground product this year. How do you cope with false positive results? So as I mentioned earlier, our accuracy rating is generally over 95%. We do offer tons of options in the software that comes with it to dial back the algorithm, to dial it forward, and by a bunch of segments. I can show it another time, but it's highly configurable, as you can turn things off, turn things on, change the sensitivity for different types of events and faults. So, if you are in a situation that we haven't seen yet, but where our devices are causing false positives in a certain site location, that can be adjusted, and not just globally, but down to the specific data concentrator. So if let's say you have one site, everything else is working fine, there's one site out, somewhere, and that one is always given a false positive. We can just work with you to modify those settings very easily, and you don't have to change everything. Another question, with the line type concentrator, can you also put in 9 sensors? And the question, or that the answer to that is yes. Either the line type concentrator or the pole mount can support up to 9 sensors. How do we know the battery supercapacitor is working? Have we tested it? This person says, sometimes I've gotten a problem where this has not worked, or there's been an issue with the supercapacitor with other fault sensors. And I could say, you know it's working because in the software, you have every time you click on a sensor group or those green dots, you're seeing the supercapacitor voltage and details. So we know through constant, connectivity of the system, whether that part of it is working, and will show an alarm or notify if there's a failure. But we can definitely tell if that's working. And it's not easy, it's not hard to do. So the question, you mentioned no calibration is required post-deployment. How many measurements are we getting? And could you have any evidence of this claim? We are getting, we concentrate on a few measurements. So it's the current amps, including the current waveform recording, as we mentioned, the E field and the E field waveform recording. We derive harvesting voltage. We don't have a voltage measure on there due to cost. We do the temperature of the conductor, the time clock, the GPS, and then we have the algorithm running. Hopefully I didn't miss anything there. To my best understanding from doing this a little while, we don't require any post-sale calibration, that everything is contained with that CT. Everything we measure is self-contained, and there's no calibration required. I know that's been, I think, a competitive advantage for us. Honestly, I've heard that recently, that some others require more calibration work. And I can certainly get into with product post-call. If you want to follow up with me on that, I'll be glad to get more answers on that. What's the maximum line current the sensor can withstand lightning hits? So the official range for measurements 0 to 630 amps. But I was actually asked the same question around the maximum spike current the other week, and I don't have it in front of me, but I think it was sub 1,000. I want to say it was 800 something or 900 something. I could get the number for the spike event, but it was a good number. It was a number that was favorable to us because it is designed to handle a lightning event and to recognize that event and to survive that event. The conductor range the sensor can clip into, I always forget. It's everything with the biggest one. Let's see if I can quickly look at specs. So the question is, what conductor range can the sensor clip onto? And it is from 9 to 26.8 millimeter or 35 to 240 millimeters squared. So again, 9 to 26.8 millimeter. So I've gotten feedback on this one that is good. There's I think a larger size that not just us, but a number of sensors have issues with, but it can also be an insulated conductor, and so we support most of the conductor sizes. We're almost through the questions here. Let's see. With a sensitive earth fault, what's the lowest earth fault current it can pick up? I'm gonna have to research that one. I'm not sure what the lowest earth fault current it can pick up. I know that the earth fault is the fundamental of the system, and the first version of this, 8 years ago, was just a grounding fault or earth fault system. And it works down to 0.3 amps. I know that. So in low power mode, the sensors can still pick up an earth fault or ground fault. And last question, small disturbance occurred at a line. I'm not sure I have the answer on this. It's about an IDMT relay. And Sandeep, if you'd maybe follow up post-call, I don't know the answer to that one. And I will record these questions and answers. As well as I mentioned, this whole webinar was recorded. Well, I have gone through all of the questions. I appreciate all 22 questions. That was great here at the end. Again, my name is Tim Watts, here supporting Energy Utility for InHand Networks. I enjoyed the opportunity to present our products and services to you today. We'll probably do another one of these probably every month and just spotlight some of the individual products here coming up. Please feel free to reach out if anything, if I can help further, or if there's any further questions or support needed. Hope everyone stays safe and has a wonderful Easter weekend. Thank you.